Hello guys, in this video we are going to discuss the solution of the problem clone an undirected graph. So let us look at the problem statement. The problem statement says that we are given a connected undirected graph with n nodes and m edges, with each node having a distinct label from 0 to n minus 1. Create a clone of the graph. Each node in the graph contains an integer val and an array neighbor. So the data structure in which a node of a graph is stored is something like this, right? So this, let us say a node is there. What is the value of that node and what are the neighbors of that particular node? So this is how we are storing a node of a graph. Okay. So that is what is mentioned here. And given this graph, we have to create a copy of the graph, or we have to create a clone of the graph, and we have to return the reference of the clone of the graph. So let us try to understand the problem statement with the help of an example. So let me switch here. So in the example, if you see, what is given to us are the edges. Okay, so let me write down the edges here. So the edges which are given to us is 1 and 3, that's the first edge. 0 to 2, this is the second edge. And 1 to 3, third edge. And 0 to 0 and 2. Okay. So what it simply means is from node 0, I can go to first and third node. From node 1, I can go to 0 and second node. Similarly, from node 2 and node 3. And if we represent it pictorially, then the graph will look something like this. Okay. So see, these are the 4 nodes which we have, 0, 1 and 2 and 3. And then from 0 you can go to 1 and 3. So from 0 you can go to 1, and from 0 you can go to 3. So similarly for the rest of the nodes, and if you draw it in this format, you will get a graph something like this. So given this graph, we have to create a copy of this graph. Okay, so we need to create a clone or copy of the graph. All right, so that is what we have to do. And also one more thing, the node only the so in the function which is given to us, which is clone graph, only one node is given to us. So this particular node with 0 is given to us. Now let us discuss the solution of the problem. Okay, so let us say that this is the graph which is given to us, and this is our old graph which is given to us. And what we want to do is we want to make a copy of this graph. So in order to make a copy of this graph, we will start from so we will take a queue. Okay, and initially what we are going to do is that we are going to put the first element in the queue, which is equals to 0. All right, and then what we are going to do is we are going to iterate on the elements of the queue, and we will iterate till the queue is empty. So in the first step within the loop, while queue is not empty, in that particular loop, the first step what we are going to do is we are going to dequeue an element from the queue. So let us dequeue an element from the queue. This is how we dequeue it. Now what we are going to do is, so here this remember this X node corresponds to the old graph, okay, or the entry in the old graph, or the nodes of the old graph. Okay, so what we are going to check is, the first thing which we are going to check is whether this X, I have made an entry or I have made a corresponding node in the new graph or not. So the first thing which we are going to check is whether X, or let me just write it down like this, corresponding entry of X, corresponding entry or corresponding node, right? Corresponding node of X is there in new graph. Okay, whether the corresponding node we have created in new graph is or not is something which we are going to check. So in this particular case, our new graph does not have the corresponding entry. All right, so this is, let us say this is the new graph which we are creating, and here we don't have the corresponding entry. So what we are going to do is we are going to create a corresponding node or a node corresponding to 0th node. So this is the node we have created, and let us say that that node is represented by new node. Okay, so new node. So let's write in little bit of pseudo format also. So so the first thing which we check whether x is in old to new. Okay, I'll explain this, but let me just write it down. If x is old to new, then the new node is equals to old to new x. Otherwise, and this is the case which we have just discussed, which is basically I am going to create a new node. So here I have created a new node, and right now what I did is I have just set its value, and the neighbors I have kept it as empty. Okay, so I have just initialized it with the value of the node, but the neighbors I have kept it as empty. All right, and also while doing so, while creating an entry, I'm going to make an entry in this dictionary. So old to new is a dictionary. Okay, and x is equals to new node. All right, so let me explain this. Old to new is the dictionary where we are keeping a mapping from old node to the new node. All right, so our dictionary old to new is something like this. Let me just draw it here. All right, so this is the dictionary which we are maintaining, and it just contain an entry from old to new. So in old node or in old graph, the 0th node is, let us say, is represented by this. Okay, 0, and in new graph this is represented by 0. Remember, right now I am denoting it with zeros only, but this is actually not 0, but this is a reference of node. So in that way the old and new entry differs, right? I hope that makes sense. Okay, so now let's go back to these 3 steps, or these 4 steps. So what I did is, first I popped an element from the queue. So this element I have popped it. Now I checked whether the corresponding node, we have made an entry in the new graph or not. Right now the 0th node entry we did not made in the graph, so that is why, since it does not exist, so we have populated. Since the 0th node in the new graph does not exist, so this portion of the if else condition got executed. Let us say that that particular node or the corresponding entry exists, then in such cases I will just, rather than creating an entry, I'll just go ahead and fetch that particular node value from the old to new dictionary. All right. Okay, so after doing this, now in the 5th state, what we are going to do is we are going to, so far in the new graph I have just created a node. Now I need to uh, correctly or I need to point to the correct neighbors, right? So now let us adjust the neighbors here. So to adjust the neighbors, what I am going to do is I will iterate on the neighbors of x. All right, so for neighbors in x dot neighbors, remember this x is in the old graph. All right, so I'm going to iterate on this, and what I'm going to check is if this n exists, or let me just write it down like this. If n exists in old to new, which simply means whether I have already created this node or not. If I have already created this node, then I will say my new neighbor is equals to, let us just get that neighbor from here, old to new and neighbor. Let us say in the case that my neighbor does not exist in the old to new dictionary, then again I have to create a new neighbor here, or I have to create a new node. And again what we are going to do is we are just relying on, so this is neighbor dot value. I'll just create the neighbor dot value, and I will let the neighbors of this thing remain as it is. So see, this old to new also simply means that whether I'm seeing a current node or the node in question for the first time or for the second time or not for the first time, right? So if I am seeing it for the first time, then I'm making an entry, and I'm making an entry in the old to new also. So let us make an entry in old to new. So old to new, this is my new old node, and the corresponding new node is this. Okay. And if I'm seeing it for the first time, then I have to iterate on it, and that is why I'm going to put this on the queue. Okay. So I will put this n on the queue. So now let's execute this, or let's execute it over the example. So our neighbor was what? 0th neighbor is 1 and 3. So let us say we pick the first node. So one node does not exist in the old to new. So let's first, what we did is, let's make an entry of 1 to 1 over here. After making the entry, we also have to put that element in the queue. So let's put that element in the queue. So remember, queue here was this. Now let's put this 1 over also here. And after doing that, what we are going to do is we are going to append this. So remember here, the new node neighbor is null here, right? Nothing is there in the new node. Let us adjust the neighbors now. So now the new node dot neighbors, and neighbors is in the list format, dot append. So append an element to the neighbor, and let us append the new neighbor. Okay, and we will append it here. So let me just write it down as 7 here. So now let's make an entry here. So what we did is we created a one node, this, and we have corrected this entry. All right. Now the next neighbor is 3. So this is 3, right? The next neighbor of 0 is 3, right? So again we have corrected this, and see here 3 does not exist in the old to new. So this will be 3, and here we have created an entry, and also here also in the queue we will have 3 here. Okay. So this is pretty much the logic or the code for it. Now let's run it over an example. So now again, what will happen now, we will again dequeue one element from the queue. This time we will, let us say we dequeued 1. So 1, we saw that we already have an entry of 1, so we no need to create. So this is this second and third and fourth step I'm talking about. So one entry already exists in old to new dictionary, right? So this entry already exists. So I'll get the node from the old to new dictionary, and I will put it there here in the new node. And then I will go ahead, and right now the neighbors of 1 are not pointing correctly. So now we will go ahead and ensure that they are pointing it correctly to, or pointing it to the correct nodes. So 1, if you see, the neighbors of 1 are what? 0 and 1. So 0 already is there, and since 0 is something, the entry of 0 is already there in old to new, so we are not going to put it in the queue. Remember, only once we see a node for the first time, we are going to put its entry in the queue. All right, so that is why for 0 we are not going to make an entry in the queue, whereas once we see 2, we are going to make an entry in the queue. So this 2, and here also we will have an entry of 2, and see this 2 does not exist here, so 2 and 2. Okay, now let's move forward. So again we will go ahead and dequeue an element from the queue. So this time it will be 3. 3 exists in old to new dictionary, right? Old to new dictionary. So the new node will contain 3. This particular thing, this condition will be satisfied, and we will have new node with us. And now let us correct the neighbors of it. So now the neighbors of 3 points to 0 and 2. And 0 and 2, both entries are there in the old to new dictionary. That is why we are not going to put anything on the queue. Okay, just what we are going to do is we are going to adjust this. We are going to make this entry point correctly. So 3 points to 0 and 3 points to 2. Now the next element we are going to dequeue is 2. 2 also exists in the old to new dictionary, so nothing will be appended on the queue. It is just that we have to ensure that the neighbors of 2 are correctly pointed to. So the neighbors of 2 is what? 1 and 0. So let's make that entry. So the neighbors of 2 is 1 and the neighbors of 2 is 1 and 3. So this is 1 and this is 3. So this is how we will be able to do that. Or we will be able to create a new graph, and towards the end this old to new dictionary will be there with us. What we are going to do is we are going to return old to new, okay, and we are going to return the first node which we have, which is what? Node. This will be more clear once I go through the code. But that's about the explanation, folks. I hope you were able to follow it. Now let's switch to the coding section and we will see how we will be able to code it. So let's look at the code. So this is the function which we need to write. So this line is basically, this has nothing to do with our code, but if you see in the driver code, they are using recursion. So this is the driver code which we have. And this you compare function, if you see, they are using recursion over here. And since here for the larger inputs, the number of recursion will exhaust the default environment setting. That is why we have to set the recursion limit here. But again, this has nothing to do with our code because we are not using recursion. It is just there in the driver code, and if you don't use these 2 lines, for some test case our solution was failing. But anyways, okay, so now let's move forward and let us look at the algorithm. Now if it is a null node, which is an empty graph, then we are going to return an empty graph. If it is not, then we will have an old to new dictionary with us, and we will maintain a queue, and the first node, which is what we are going to put that on the queue, and then we are going to iterate while the queue is not empty. Now what we are going to do is we are going to get the first element from the queue, and then we are going to check whether that X, the entry or the corresponding node, is there in the new graph or not. So this is how we are checking whether, is this the first time I'm seeing this node? If this is the first time I'm seeing this node, then I'm going to create a new, if this is the first time I'm seeing this node, then I'm going to create a new node, and I'm going to make the corresponding entry in the old to new dictionary. If this is not the first time I'm seeing this node, then I will go ahead and fetch the corresponding reference in the new graph, okay, and the reference will be pointed by new node. All right, now new node is there with us. Now we want to adjust its neighbor. So now this is the neighbor, we are iterating on the neighbors. If the neighbors are being seen for the first time, then we create a node for the neighbor, and we again go ahead and push it there in old to new dictionary. And in this case, we are also going ahead and putting it in our queue, right? So we are appending the neighbor in the queue. If this is not the first case, I'll just go ahead and get the new neighbor, okay, and then finally we are going ahead and ensuring that the neighbors point to the node correctly, and this is how we are doing it. And towards the end, this is what I was talking about. Old to new contains all the nodes and the corresponding new node. So that's about the code, folks. Now let us submit the solution. So our solution got accepted. That's from this video, folks. In case if you have any questions or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.